Afternoon, folks. Welcome back to Physics with Captain Rod. I'm making this one to help you out with number 28 in your homework. So let's see. Find the average power delivered if this car accelerates from 20 to 60 mile per hour in 4 seconds. All right. So finding the average power. So a lot like the last video that I made. All right, let's start with this. Power is equal to change in energy over change in time. It's the rate that energy is transferred. Okay. Start by converting these to meter per second using this conversion factor. 1,609 meters is equal to 1 mile. That should help you out with that. All right. Then calculate a kinetic energy at this speed, using meter per second as your speed though, and then calculate a kinetic energy at this speed. Then subtract those kinetic energies, and there is your change in energy. Then divide it by your change in time, and that will give you a number, probably be a pretty large number. And then use the conversion factor. There's 746 watts in 1 horsepower. Sorry about my crummy writing there. That's a 746. All right. Looking at some of these other questions here. Find the instantaneous power delivered when the car is moving 20 miles per hour and accelerating, and when the car is at 59 miles per hour and accelerating. Now, there's kind of a reason why I worded it like that. It's not super important for right now, but this is important. Still accelerating. All right. You're going to need these numbers in meter per second. This one you're already going to have. You're going to basically have that one too. I think you can use the 60. It will be okay, but if you want to go ahead and calculate a more accurate value, use the 59 mile per hour. And to find instantaneous powers, it's a little trickier to find instantaneous powers by the change in energy over change in time. I recommend calculating it like this. All right, power, work over time. Work, remember, is force times distance over time. And distance over time is velocity. So force times velocity gives you your instantaneous power. You'll have velocities here and here, so no problem there. The big question is, what do we do about the force? All right. Well, draw a free body diagram of this car. And I'll give you a clue. There should be 2 vertical forces and 1 horizontal force. Now, I would go ahead and state out we're going to ignore air drag for this problem. And the 2 vertical forces are going to add to 0. So the net force acting on the car is the horizontal force. I don't want to tell you what force it is or what it's called. I'll let you think about that in your free body. And that's what you're going to use for this. Now, the question is, how do we actually get a value from Newton's second law? Once you have that free body, write out that whatever that force is equal to mass times the acceleration of the car. And the mass is given, and the acceleration you can get from previous stuff mentioned in the problem. There's the delta t, 4 seconds, and you can get the velocity change from these 2 numbers in meter per second. So that should get you through 28. Oh, whoops, here's another one here. Part B, find the force put on by the seat onto the driver. So draw a free body of the driver. Here's my quick stick picture of the driver. And then think about the different forces acting on the driver. I would put 3 different forces on there. Obviously there's a gravitational force. Now, the driver's not accelerating down, right? It's not a free fall. And then ask yourself, well, why not? And think in terms of forces. There's got to be a force on the driver to keep the driver from, falling. Then the driver is accelerating with the car, right? So think about what's doing that and put those in your free body. Then write a pair of Newton second law equations, one for this direction, and that should give you a force on the person, no problem. And then write another Newton's second law equation for this direction, that should give you another force. And both of those forces are acting on this person. So when you look up the answer to this, I think I put this in my handout. You'll notice there's two forces. I think one left and one up. So that should hopefully get you through this problem. Hope you're having a great day. Enjoy.